Okay, so for repeated linear factors, in the first step, it's much longer than usual, but it starts out very similar to when we have distinct linear factors. We need to factor the denominator. So I'm going to write out a scrap area over here. So our denominator has 3 terms, and you should always check to see if you can factor by your greatest common factor first, which we can because each term has an x in it, at least one, so we can factor that out. And we're left in parentheses with a trinomial. And so I'm just going to repeat that first factor of x. The trinomial can split up into 2 parentheses. X times x is x squared. 1 times 1 is 1, and if these are both positive, my outer and inner terms become that positive 2x, and it checks that it multiplies to a positive 1 at the end. So these are my factors for my denominator. Notice how x plus 1 repeats. So this is a repeated linear factor. So x is a distinct linear factor, but the quantity of x plus 1 can be squared to indicate we have a repeating linear factor. Whoops, sorry, I didn't mean to lose that. So what's being squared is linear. If you graph the line y equals x plus 1, that would come up as a line. So with that being said, that's what's going on with the rest of number 1. It's describing what we should do for our partial fraction decomposition, like how to set it up. So step 1, let me write out the problem. Oops, didn't mean to look like it crossed out. I'm just making a denominator. That's okay. I think you guys know what I mean. So for our distinct linear factor of x, that's fine. But for the quantity of x plus 1, we need to establish that it is to the first power because it can evenly divide into our denominator here just as much as x could. It evenly divides. And x plus 1 squared can evenly divide into our denominator, leaving us with x, by the way. And that's why we list these as we do, okay? Do not think that we weren't doing this before. We were with distinct linear factors. And just like with distinct linear factors, we're describing all of these as linear factors, even a repeated linear factor. Okay? We have constants above it because it's always 1 degree less. Okay? And so we actually did step 2 in here as well because I gave the denominators of a, b, and c. So we're up to step 3. Okay, so for step 3, I'm multiplying everything by the common denominator. I'm kind of running out of space here. I'm going to squeeze it up here. And so if I write that up there, I'm not making it an exponent. I just ran out of space. Multiplying everything by the common denominator. So if I multiply with my first fraction, the denominator canceled completely and I'm left with just my numerator. If I multiply to my second fraction, the x is canceled and a can be multiplied with the quantity of x plus 1 squared. If I multiply with my third fraction, b would be multiplied with x times the quantity of x plus 1, because only one of these would end up canceling, so there is no square. Whereas in my fourth fraction, the whole x plus 1 squared cancels. So c is going to be multiplied by x. This is why it's so important to not think of it as cross-multiplying. Always think that you're multiplying each fraction by the common denominator so you cancel out appropriately. Okay, I don't want c to be multiplied with x plus 1 or something like that. This would be your correct next step. So we're up to number 4. So in number 4, this is to use one of the methods to find the partial fraction decomposition. If it doesn't work well, use the other method. I'm going to use matching coefficients because we don't see a lot of that in the textbook. And so I'm just going to proceed so you see another example with it done to match coefficients. So I'm going to multiply A to this quantity. Now my scrapbook, I had it written out before. So I'm just adding that to the bottom. You can remember that. Look at your notes. You have it there. So A would be multiplied with x squared, and we're going to write this as 2ax, just like we write 2 pi r, certain format, and 1 times A is A. Now I'm going to multiply bx to the quantity of x plus 1, so it's bx squared plus bx, that's a b. My b's look like 13s a little. That's a b. And c is already multiplied by x. So let's combine like terms. I'm going to regroup this a little. So A and B are being multiplied by x squared. And we have 2a multiplied by x as well as b and c. Let me try a better parentheses there. And my 2 looks silly. That's okay. And my only constant is a. That's a good thing when we're matching up. So we're matching coefficients. So 15 is a plus b. 20 is 2a plus b plus c. And 6 is a. So we already know what 6 is a. And that means that we can solve for b. B would be 9. And if we know a and b, then we can solve for c. C is -1. Okay, and our last step. So 15x squared and 20x plus 6 over x cubed plus 2x squared plus x. That's a little sloppy, but we can see the original problem. It's going to equal 6 over x, because that's our a, and 9 over x plus 1, and always put a plus sign, that helps later. -1 over the quantity of x plus 1 squared. That's it. We got our answer. Good luck.